Alright, another draft physics video presentation. I think we'll just do some overview type stuff, but more on the subject of the conventional story of reality, which is, a bunch of different stories. So in one place, or I could put it over here, I suppose, we have this thing called quantum mechanics. And then over here, we could say we have relativity, Einstein's story. And these are idea bubbles or something, clouds of perception and belief, and then connecting these things are different associated things. We could say is the key to say quantum mechanics is something called a virtual photon. It's the force carrier of things like magnetism and electricity is these fields of a thing that behaves like a photon, except it's they can't explain where it comes from, so they have to call it virtual. And then you have something called a wave, some sort of EM wave. We'll just put a W. Theory that somehow this stuff, these virtual photons, are somehow EM waving in some way that makes them interfere with each other, have problems interacting. Now, relativity doesn't really connect to that stuff at all, but it has its own little catches of the thing called spacetime, which I guess I could just stick in over here. Time dilation is some component, as if time is an actual dimension that somehow places in space or in a different place in time. Like somehow time isn't something the whole universe is having the same experience with, that somehow you can have different experiences with time and space. And the other component to the relativity thing would be the idea of the convergence, the bent space. Now, the bending of the space that's kind of a fake, because the mathematics isn't a bend. The mathematics is actually a convergence, something I could draw up here maybe. When they do the math, what they're really saying is happening is that all the little matter bits are somehow consuming space as if it was a fluid, and the space is moving in towards their center of gravity, the little bit in the center to them, and that every particle is somehow consuming space like a fluid, and the stuff around it is being driven by the fluid flow. So they describe it essentially like something, I would make the simple argument that description could be understood as either pressure in the fluid that comes from the outside, or you have to say that there's a lack of pressure on the inside, that somehow the inside is vacuuming the stuff. Now, the problem with these theories is their energy problem. I mean, here they deal with energy, by virtualizing it. And here, in the Einstein description, there is no explanation for where the energy comes from. They won't say it's a pushing fluid, and they won't explain a pulling fluid. They'll just say it's a bent geodesic. They'll just say it's a they'll give you images that just rely on gravity. Like I say, the bent fabric relies on gravity to explain gravity. Obviously, you don't have to know where the force comes from to watch something fall down a slope. We're already visually, and our instinct or our reflex, our intelligent reflex is to understand that things fall down hills. And so they give you a bunch of visual signals that tell you where the energy comes from without telling you where the energy comes from. And so obviously the bent space model is using gravity, you know, to illustrate gravity, which is just such a cheat. And you should know that's kind of garbage. Now, connected to this is also entanglement and other many universes and all kinds of other crap they've invented. The 100 or so extra, or 200 extra particles that nobody can understand what role they play, so I just put them in here. You know, these 200 extra particles. I don't know who to blame, quantum mechanics or relativity, for their existence. But regardless. So this is their model, and so I'm just going to attempt to illustrate that their model does have the components of my model. I mean, it does have Einstein's convergence is sensible in terms of that's Mach gravity. So if you take his mathematics, it's basically describing Mach gravity. Now it does it in such a way, you know, by using fluids that don't exist, by using analogies, okay, rather than using saying something explicitly, that they don't have to explain any problems with drag or any other issues, because they're saying this bent geodesic, you know, just doesn't have any properties other than the one property. It's sort of like their invention of dark matter. They just make something that does everything they want it to do and nothing they don't want it to do. Just a magical substance, and that's what bent space is. It's a magical substance. All right, and so you know, I've sort of gone over the evidence that convinces people that these things are the truth. And so for quantum mechanics, you have the two-slit experiment. I don't have any more room to draw, right? So for quantum mechanics, you have the two-slit, you know, wave thing. And so that's sort of the foundation experiment that tells them this must be true. Wave interference, photons aren't particles anymore. They're some sort of waving thing in some sort of ethery thing, just not really well described. And the key thing for Einstein was, well, basically two things, was the Eddington experiment, you know, demonstrating, you know, in a very bad way, very poorly in terms of being hard evidence, that somehow photons were affected by gravity, which it doesn't seem like that's critical to anything, but it's sort of critical to this notion that this force, Einstein's force, is somehow does have energy in it, because it somehow is bending photons through this process. And also by bending photons, by fiddling with a photon, you're some other way of getting to this time dilation, right? I mean, this is the space-time, which is the, you know, I can't fit a clock in there. Put one over here maybe. So this idea that time is not a real thing, you know, that, you know, time is a thing that you can somehow dimensionalize and that you can change it. Alright, so, you know, I have to take some of this one at a time, so I guess we can get rid of some of the components and, you know, attempt, what the hell is that? Battery, I guess. Not critical to any of this. So we probably don't need the virtual photon. We don't need some of this stuff down here, so we'll try to make more room. And we'll maybe just wipe out all of this and start over. So now you got the idea that that's their physics is based on. These two, the real important parts is space-time, okay, the dimension of space-time, the implications of space-time. I could put it way up here. Yeah, I could do that way up here. Space-time. Alright, just get rid of this little bit of nothing. And the virtual photon of quantum mechanics. Yeah, that's strange how my view is different than your view. Yeah, this is much, what's a straight line? It's not a straight line from your perspective as it is from my perspective. Sort of, you can sort of see that obviously. A little bit obvious. Alright. All right, so, and it's their inability to match these two things. So this is Einstein's relativity, and this is quantum mechanics, right? So we could just put a little r here and a q here. Okay, so you can't see that. Well, tough. I guess I could just go like this. Oh, the speaker's wire has to do its thing. Definitely gotta get a new wire. Stop it. Stop it. Unplug you. Alright. Well, anyway, you get the idea. You probably should be following along. And so, unification of these two things, making a clear picture of, to say that here we got two things. Now they've established that, through Maxwell, that the photon, is moving the same speed as the virtual photons of magnetism. And so these, what seem like the whole electromagnetic spectrum is all the same speed. It's all photons. And there's obviously a connection between those things, and that connection you have to somehow make this so this gravity thing is happening at the same speed as everything else. So all of the stuff that's going really fast is going really fast the same speed. And these two have that obvious connection. So the speed of space-time, that is how fast a gravitational wave, if there were such a thing, would move, is the same speed that this virtual photon is moving, which is the same speed that a regular photon moves, which sort of gives you reason to think there has to be a connection between this stuff. There can't just all be, there can't be two separate mechanisms that have exactly the same elemental functions that function at exactly the same speed. It just doesn't seem very logical that that would be how the universe works. That two completely different, a bent geodesic and a thing that behaves just like a little corpuscle of energy, a quantizable corpuscle. This flow, they can't quantize the flow because it's not particles that are flowing. This space-time, this bent geodesic doesn't create anything you can quantize. So it doesn't have a Planck anything to it. So it doesn't fit with this quantum mechanics thing. All right, so I would argue that there's obviously mistakes been made, and the mistakes are egregious but subtle. They're not, like I said, if you really look at how they do space-time, they do space-time by basically pointing out its mock gravity. They basically accept, the equation accepts my theory. Okay, that you could either have it as an internal sucking or an external blowing, but stuff is getting blown in or it's getting sucked in. So obviously I'm arguing that the force obviously does come from the outside. So that resolves part of that space-time thing in the sense that, okay, well, let's go with that. And now that we've made it a real force, though, that now we have to explain drag. Now, I've explained drag in the sense that drag does exist. I don't want to write drag. This idea that, okay, so you have a good mechanism, this convergence, this external pressure is good at explaining, this, it explains why things are spherical. It explains a lot of things. So if you think it is an external pressure, just like the cosmic background radiation, except a lot more of it, it explains a lot about what gravity is. So you can just turn gravity into the virtual photon and then just make the photons real. Now, if you make the photons real, my argument to you is if you make these gravity stuff real, and so you're making an external pushing force, okay, it's as Leonard Susskind calls it, an anti-divergence. Now, what he means by divergence is this part. Okay, if you reverse these arrows, they're getting further apart with distance. Now, he calls it an anti-divergence because he doesn't want to say convergence. Okay, he's just trying to run away from that word. But anyway, but that's what's happening. Everything converges because everything's converging on the center of gravity, and it's not really converging on the center. What it's doing is going right through it. So all of these lines go through the center, and so when you go this way through and then you go this way, that's equal. So, you know, it's ends up being the center of its gravity, but there's no actual center of gravity that's causing the phenomenon. What's causing the phenomenon is, as I've pointed out, if I take a bunch of random stuff, you know, just random arrows going in all directions, little force bits, from anything's perspective, anything put in that field at any location, everything that hits it will be perfectly geometric. I mean, it'll have everything going, you know, it's going to seem like the universe is pointed right at it from its perspective. And so everything will see the universe or experience it or interact with the universe in this very perfect radial way from a universe of even energy. And so it'll end up having that mathematical precision of this perfect convergence. And again, that's Mach gravity. So if you make these little things real, you know, and make them things, little bits of energy rather than a flow of a fluid, you just make them little quanta of energy. And then you connect this to the idea of the virtual photons that's the carrier for magnetism, and what they call electricity, but they're not really separate things. You can sort of get the idea that Maxwell's equations that basically just describe a radial force, that is a force that somehow, you know, from a straight line from its center, does the same thing in terms of it interacts with the universe in this straight line manner from an infinitesimally small center. And you know, that's, now you can connect these two things. So the external pressure is in this form of little bits of energy moving towards a center. The idea of charge is basically two things that have the same effect. They're expelling a charge that has a different effect. Now, you know, the irony is that, you know, you can find drawings of charge where it's in two colors, and the only thing really missing is they don't think of the force in two colors, two ways of thinking about the force, actually, these little bits being in two colors. And so that's the only thing you have to kind of understand, is that if you do that, if you recognize that the force is two different forces, then it's going to affect two different things, and then you do the simple thing of understanding that the proton is, well, let's do the, yeah, the proton should always be the red thing, because, you know, it's the positive because of Benjamin Franklin's error. But anyway, and the electron, and they're the key players. Now all these 150 other, 200 other little particles they've made up, neutrinos and all this crap, they really don't play any role in any of this that they can identify. So when they build an atom, they don't put neutrinos in it, they don't put muons in it, they don't put any of this crap in it, because it doesn't have any role to play. And it's only when they do something inside of accelerators, you know, that they can even see these things, and they see them for, you know, portions of a second. So they're really not playing any role. They're just pieces of this stuff, a force. You know, they could just be a clump of arrows. They could just be a clump of the little bits, and they're calling it a particle when it's just a force. But anyway, I don't want to get too far away. I'm just saying this is how, you know, they're close if they would just let go of their lingo and let go of the thing they've become attached to. So if you just get rid of this idea of some geodesic causing this effect and just account for it with something real, say it has to be a little piece of something, a piece of energy. And like I said, because of quantum mechanics, you really do want to say it's a piece. It's a clump, as Feynman would say. You don't want to say it's a part of an undefined amount of continuum or something. It just makes perfect sense to say, yes, you can quantize gravity. You can, as long as you make it into a substance that can be quantized. You can't quantize the geodesic is the problem. All right, but anyway, And then you understand that, when Maxwell drew equations for charge, those drawings, okay, would have lines of force, and then those lines of force would create what would be described as field lines. I mean, lines that would illustrate, how the charge changes through the interaction. So I didn't draw this very well, but these lines would be building. They'd get thinner and thinner here, all right, and they'd be wider and wider out here, and that kind of thing. When two charges interact with each other. And so these lines, the field lines, are just describing what the net effect is of having two things close to each other. But the lines of force, that is, these lines, are the ones that are really in the mathematics. These are the lines that, like here, the anti-divergence, the same effect. These lines diverge, and they diverge in two dimensions, which means they create a square. They go both ways, creating a square. And that's the inverse square law that plays such a role. And again, it creates dipoles. You can see pretty obviously that electrons and protons in every way fit the description of a monopole of charge. So we know it's the electrons are all negative and the protons are all positive. They absolutely, if you were to say what would a monopole of charge look like, well, that's what it would look like. It would look like an electron, or it would look like a proton. And yet they're afraid to say it because Maxwell said there wasn't any, for no really good reason. There's no truth to it, as it doesn't break anything to all of a sudden say, yes, there is magnetic monopoles and they are electrons and protons. It doesn't break the math in any particular way to do that. So anyway, so that's how, they're pretty close. So I'm not like saying, oh, physics is way off. I'm just saying but they're so tied to these concepts. So they're so tied, they've so connected quantum mechanics to wave mechanics, and there's just no place for waves in here, right? There's no waves in here. Now, if I move this thing a lot, then obviously I'm going to move the field a lot, and I'm going to create something that could look like this pressure would be in this location, and then the pressure would be in this location, and the pressure would be in this location, and the pressure would go back to this location. So I can make something that looks like a wave, but that's an emergent property. It's not something fundamentally built into, especially not built into this radiation. This radiation doesn't wave. You have to wave the particle to wave the radiation. And the only way you can wave the particles, you have to move it. That means you have to move something charged near it that's creating more of this force. Now, the simple thing, again, that I added here was two colors. So to understand that there's two kinds of force, and the two kinds of force obviously have to be inversely affecting protons and electrons. Right? One force has to be doing something to the electron, and it does exactly the opposite to the proton, and vice versa. And I've sort of explained that simple difference is just the difference between reflecting a force versus diverting a force. So a force goes in and it just gets diverted. And this gets a bit of momentum through this process. And that's it. Not that complicated. It's simple to understand, and then you can understand why you can build up, like if these were like charges, how they would build up a lot of pressure because the reflections would be essentially infinite. They would just, this little bit of energy doesn't go through, so to speak, and instead gets trapped and is creating more and more pressure as you bring the two things closer together. I mean, the concept is so simple. Ping pong paddle, ping pong ball, closer together, you hear more bang, 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 bang. Each time you hear a bang, it's always the same amount of energy because this virtual piece always moves the same speed. It never changes speed. It never, this little I'm trying to think of a line of force. They're always moving the same speed. They're always moving the speed of light. They don't move faster, they don't move slower. and they're always made of the same stuff. You can't change what they're made out of. They are what they are, and so every time they hit, it's always the same impact. So if you create more impacts, you're obviously creating more energy. You're realizing more energy. And so proximity creates a kind of energy, between particles. Either the illusion of more energy being on the outside, because there's low pressure. So if there's no reflections, that is, if you did have an electron next to a proton, you can understand that the red force is leaking out of the electron, and the black force, the force the electron is emanating, reflecting, is leaking out of the proton. And so you don't have any reflections in between them, and therefore this external pressure, the same external pressure that exists here for gravity, this external pressure will do all the pushing for you. So now the force of gravity is essentially magnified by eliminating force in between the two objects. And as pointed out, if I have two electrons next to each other, exactly the opposite effect will happen. All the force in between will reflect many, many times. So each bit will have more energy, and the closer they are, the more they impact. And so obviously the pressure would be causing both the objects to move away from each other. Now, I've explained the mechanism of an electron, the fact that it's absorbing the energy, that the energy goes in and energy comes out, and that changes the disposition of the internal structure in the sense that it now has a bias in a direction. It has a component in that direction because it's essentially absorbing the energy. So all acceleration is an absorption of force. And now you can understand gravitationally why gravity works, is just because when a body moves by absorbing just the field energy, I didn't hit it with an extra photon. I mean, we don't hit the Earth with extra photons to push it into the sun. So obviously the energy is coming not from the external world to push the Earth. There's not more external pressure. There somehow has to be less internal. The distance between the Earth and the sun somehow has to have less stuff in it. And that less stuff can be understood as, well, it absorbed a piece of energy going this way and it gave away a piece going that way. Well, how could something over here see this? It's not going to know that extra energy went this way. It's certainly not going to feel it. So obviously the energy that was supposed to hit this object doesn't hit this object, then this object's going to move into it. I mean, it's that simple. So there's nothing here that's totally alien from what they're saying. It's consistent with their mathematics. Like I said, this is Maxwell all over the place. These lines of force, the divergence of the lines of force are what creates the inverse square law, and it's completely connected to the gravity in the sense that it's the same inverse square law. It's the same divergence of the force. It's the same straight line model of the force. Again, no waves involved. So it's not like I'm saying it's some harsh conspiracy of stupidity or something. They just missed, some details because they got stuck on concepts, like bending a geodesic and creating waves. And instead of saying, well, what's the geodesic really made out of? What's this phenomenon, this warping? What's the real elements, And so they're just stuck with thinking about it as if space is a thing, a material, a fabric, when no, space is nothing. And there's actually something in the space, and it's this something, the little bits, the photons, the elements of photons, you could argue, that are gravity. Now, I would argue that the photon is really just it's an impact, a sequence of impacts. You can't really see those, but whatever. And that gravity is a sequence that's too small a bit. It's not enough of a frequency for us to detect with any instruments, and that you need a certain number to be able to do what you need to do to an electron to create the phenomenon of electricity, essentially, to be able to detect this force. The only way we really can detect it is we have to have this charge interaction take place, and we have to have communication between electrons for us to detect the force. If the thing just moves a little bit, over here a little bit, or over here a little bit, we can't, oh, okay, you can't see that. We can't detect it. But that's what most of the universe is full of, is those bits, those chunks, those pieces of a photon. And the pieces of a photon are what gravity is, and it's essentially illustrated by the cosmic background radiation, which in a sense is of unknown origin, really. But it's clearly, you could argue that if there was a continuous force that always exists in the universe, that empty space was full of bits of stuff flying around, you could argue that sometimes, just by coincidence, those bits would create a frequency. That is, they would all be going the same way and have a consistent distance between them. And it would be a big enough piece for us to see sometimes. There'd be a higher probability that would only be, say if we needed 4 of these things to be able to move an electron sufficiently to create an electric current. But you could understand that if this was happening just by randomness of the field, that it's more likely to create these 3 chunks, and even more likely to create the 2 chunks, and even more likely to create 1 chunks. So there could be a whole bunch of this energy that sits layers underneath the layer we can see. So we see the cosmic background radiation, we see lots of radio waves and microwaves that seem to be spontaneous in their origin. We don't have any place. We can't say they came from something. They came from the Big Bang, they say, but we don't know where it came from, what its history is, what its origin is. But clearly the energy is there because we see it, and you can just speculate that there could be a lot more of it that we can't see because it's not in sufficient chunks to cause the electrical phenomenon we need. Enough movement in an electron, and that's all we're really talking about, is enough movement in an electron for us to be able to detect it. So it can be moving electrons. Electrons can be moving quite a bit, and we can only see them when they move this far. Okay, well, you can't see that. Okay, the arrow did end. There, you can see. So when it moves that far, we can see it. When it moves this far, we can't see it. We can't. It's not going to blip on our detector, or the radiometer isn't going to go, the Geiger counter isn't going to go tick, 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 tick. It's not going to tell us it's there because it's not enough of a movement of an electron. So what else do I have to say? So I'm just saying it's a subtle, you don't have to work very hard. Now, I've also explained time dilation could just be understood that you're just changing the mechanics of the atoms themselves when you give them velocity. So as I sort of pointed out, the atom's sitting here and has a certain structure, has a certain clock speed, it has a certain function. And then when I accelerate it, though, as I'm pointing out, I'm doing some exchanges. I'm pumping energy in one direction. So I'm taking that circle, and I'm essentially going to make that circle have to do this, process through space. And that's the nature of acceleration, is you're basically just putting in a bias in the form of energy in one direction. You gave back energy in this opposite direction. All right, that's basically the simple Newton law. Equal opposite reactions, force for force. If you're going to take something from the universe, you have to give back something else. If you're going to move right, you have to give back left. That kind of thing. You're absorbing something. So I'm absorbing a bunch of stuff going this way. I have to give up stuff going the opposite way, and I'm going to end up now, my circle is now going to be a bigger circle. So you're going to understand, if there's a clock in there, the clock just got warped. It just got bent. And it, you can understand that the entire theory of relativity can be understood as just saying clocks break. And that's it. And as Einstein's thought experiment kind of demonstrates, I think Einstein kind of understood, and it was kind of stating that photons don't break, though. Photons are immune to your frame of reference. They don't care about your frame of reference. So when a photon is emitted from an atom, and let's say the atom is moving this way very fast, and the photon pops out, the photon doesn't have this momentum. So the atom's moving this way. The photon pops out going this way. The photon only has one momentum, and that's it. One direction it moves in. It can't do two directions. So when you shoot it perpendicular from some object moving, it doesn't go this way and this way. It doesn't go this way 50 miles an hour and then go this way, the speed of light. Doesn't happen. It's not a baseball thrown off a train. It's an independent thing in the universe. It's in the real universe, the small universe, the tiniest of the universe. And it doesn't obey this rule that somehow you can have more than one velocity and we're going to vector them and you're going to come out crooked or any of that kind of crap. Photons just don't do that. They just move in one direction, the speed of light, and they can't be given another direction. Their direction has to be exchanged. They have to go into something and exchange that direction for some other thing going some other direction. But you can never kill their momentum this way, in essence. If I give something, if this photon jumps into an atom, okay, so this photon is going that way, well, I had to give back the opposite direction, but that's not, who cares? It has to eventually give this back to the universe as this way. Okay, the photon can do things where through this interaction this could happen. Something's released this way instead of this way, or some other thing like that could happen. But that exchange has to be done inside of electrons and protons. It can't happen. The photon can't do it. The photon can't be changed. The photon's going that way. Its force going that way. And it always has to be accounted for as momentum that way. That's the conservation of energy law. So we know that, I'm just saying you can logically deduce that this photon can't be converted by this process of moving this way. You can't convert a photon that's going this way into one going this way. That's not conservation, because there's no explanation through the conversion. There's no explanation for how you made this photon into this photon. Well, what's the opposite of that photon going to be? Is that the opposite photon going to also bend? I mean, you're going to entangle them to somehow make the universe equal again? I mean, you have to bend it down that way. Yeah. So obviously there had to be a process that makes for changes in direction, but photons themselves don't do that. Einstein knew that. That was really the principle he was stating, is that photons don't care about how fast you're going forward. So if I'm going, the better example, I suppose, is to understand something's moving half the speed of light this way, and it shoots a photon ahead of it. Okay. Well, this is where Einstein was wrong, actually. This photon's going to travel the speed of light, okay, away. And this thing's going half the speed of light in the same direction. So in a sense, if this thing could see this photon, it would say this photon's only going 1/2 the speed of light. It wouldn't see the photon going the speed of light. And that's just the way it is. That's the truth. Now, okay, so Einstein was wrong about that. So Einstein's right about, well, you can't give the photon more velocity. So the photon doesn't go half this. It doesn't go the speed of light plus 1/2, 1.5 times the speed of light. So it doesn't gain velocity. If it's going the opposite way and I shoot the photon doesn't go slower away. But the idea that what you would see is clear. You would see these photons going half as fast. And if I was going 99% of the speed of light, you can understand that the photon would barely gain any velocity ahead of me. It would take it forever to get away. Now that's the time dilation sense, in the sense that you would see it moving incredibly slowly. Okay, but you're not time dilated, and the photon isn't time dilated. There's no change in time. There's clearly an absence of change in velocity. Your velocities are so similar that of course you're not going to be able to see it. It's like if you're on a train and there's a horse outside running 40 miles an hour and you're going 40 miles an hour, the horse isn't going to look like it's going 40 miles. Yes, you're going to see the legs moving and all that kind of crap, but it's not going to be going away from you at 40 miles an hour. It's not going to be disappearing over the horizon. None of that's going to happen. All right. Sorry. This was a little too low. I'm going to mark this thing so I know. I have to just get used to writing way up here. Alright, so I don't know if I need to beat this to death. So all the other subjects are kind of, like I said, entanglement, there's not even shreds of evidence for any of that. That's just this left-right argument. Alright, so the idea would be is that, I create a left-handed glove. Alright, that's his thumb. And I create a right-handed glove. His big thumb, and then his little fingers over here. Alright, and, so I create two particles that have opposite things. One is up and one is down, whatever, doesn't matter. And so that's how they're created. And so when I see they're always opposites of each other. So when I detect this, when I say it's an up, it's a right-hand glove, I know the left-hand glove is somewhere. I know it's what the other thing is going to be. So if I can capture these two things that were created on the same day, twins, and I go find one of the twins, I always know what the other twin is, which is the opposite. Okay, because I know how they were birthed. Now, they claim that they can tell the difference between something created right-handed and left-handedness and stuff that has no handedness, and it'll automatically turn out to be left and right-handedness. That they can contrive some sort of experiment where they can prove it can't be that they started this way. Well, there is no experiment that proves they didn't start this way. So that project is impossible. You can't prove this isn't how it started without in some way proving that this doesn't come out to be half and half. And then what I've sort of argued is they're trying to say it's this, they can make this not 50-50 somehow. They can make this come out 60 or 70 when they test one side. That somehow they can create a non-symmetrical connection, so it couldn't be right and left. And they're doing it using polarized light, which I've sort of explained that you can't. Polarizing filters aren't passive in the sense they don't test right and left-handedness very well. They don't test it precisely. So I've given the example of frisbee and jail bars as an analogy. Okay, so when you throw the frisbee through the jail bars, so you could have the illusion that I'm going to do a 50-50 experiment. Okay, I'm going to turn a frisbee this way. It's a simple 50-50. Half the time I'll throw it this way and half the time I'll throw it that way. Okay, so I'm doing a simple 50-50 experiment. So, but the trick is, and you say, well, this is a perfect way to do the experiment, right? I'm going to find out 50-50 because the ones going this way can't get through the bars, so they'll fail. And the ones going this way will go right through the bars, so they'll succeed, and it'll be 50-50. Well, the trick is it does turn out 50-50 for the ones going this way. Okay, you will kill all of those. So clearly this 50% of the throws will not get through the bars. But the trick is sometimes this one hits the bar straight on. Okay, and so it X's out a certain percentage by hitting the bars. So whatever the bars are as a percentage, so it depends on how thick your bars are, I suppose. But if you said your bars are 10% of the field, well then 10% of these won't make it. And so you only have 40% here. And so that will ruin your experiment. If you're trying to detect something that's 50-50, and clearly your detector isn't going to detect 50-50. It gets one part right, it doesn't get the other part right. So your experiment will have you had a wrong assumption if you thought this was a good test. And that's the problem with their entanglement experiments, is they have an assumption about their testing equipment that says this experiment will detect 50-50. And obviously the experiment doesn't do 50-50. It won't tell you what you threw. It will give you a distorted view of what you threw. So I'm just saying there's explanations like that for lots of this physics. It's really simple, as I've pointed out in some ways, but the nuance, I mean, you have to go through all the little catches and all the little details. So the detail in like the drag problem, the detail is that, you know, when Feynman says, well, drag ruins this, you know, more raindrops hit you in the front than hit you in the back. Well, it turns out it's actually true, because that's exactly what electrons and protons do. They don't maintain their momentum. They drag to a halt. They stop moving. They can't maintain velocity. If I shoot an electron into empty space, it won't keep going, like the wrench. If I throw a wrench and I throw an electron at the same time, the wrench will keep going, the electron won't. So drag is a reality in the elemental physics, and it has to be a catch. The wrench is doing something different that allows it to overcome the drag. It's dragging, but it's overcoming the drag with an internal mechanism. It actually has a motor because it's using these very principles of charge to maintain its motion. But anyway, I won't get into all that. So we'll call this a video. You know, go into some of the other stuff in another video. I mean, the whole list of other crap they say is the truth. That, again, it's not entirely wrong. It's just that they're using language they don't need to use. Calling photons a wave, thinking of them as some electromagnetic thing, is just a waste of time. It's a corpuscle of energy. As Feynman says, you don't need to make it into a wave to understand how it functions. So lose that crap, because it doesn't do you any good. It doesn't serve any real purpose. Just understand it as a vector, as Maxwell's equations basically turn it into. A piece of energy moving in straight lines, which this wavy thing doesn't really depict a straight line if you think about it. And then on the gravity subject, again, when they do the math, when you go to the hard mathematical courses, they basically turn Einstein's equations into fluid dynamic equations, basically saying that the bent geodesic basically behaves like a fluid under equal pressure, you know, in a capillary tube or something, or between two pieces of glass. You know, right? So you have two pieces of glass, flat glass, and you have a certain space open, and now all you're doing is adding pressure at one end in water, and water comes out the other end, or you're pulling the water out at one end and the water flows in from the other end. Either way you look at it, there's the same amount of fluid going in that comes out, and the fluid within the glass plate remains even, and basically obeys the inverse square law in terms of further the way you are from one of the ends will dictate how much flow there is, because the area is expanding with which the fluid is moving through. I'm just thinking that off the top of my head, that doesn't really do the inverse square law right, in my opinion, but that's how Susskind teaches it, so I'm just saying. I mean, so maybe it's just because they're grasping for any kind of physical analogy, because try to put it in physical terms, because saying bent geodesic is not physical in any rational way in 3 dimensions. It just doesn't. Bent doesn't work in 3 dimensions, because bent requires you to bend in 2 dimensions. You can't bend a fabric in 3 dimensions. So anyway, so the analogy just breaks, and so they're looking for an analogy that doesn't break, and I don't think they're even finding one. And the only one that really will work is just to understand it as a 3-dimensional field of energy moving in all directions, which for every point in space will look like a field of energy heading right towards it. anyone's perspective looking at it will look like all the guns are pointed right towards them, but they won't see any of the guns not pointed towards them. So all they see are guns, flashlights pointing at, yeah, it's like flashlights. If those flashlights pointing in all directions, right, you'd only see the flashlights pointed right at you. So it would look like it's all converging on you, when no, it's converging on every piece of space is getting hit by the same number of flashlights. They just, you can't see them unless they're pointed at you. You can't feel the force unless it's heading right for you. And I would argue that that simple perception, if you just take that simple rule and said, okay, that's a rule I'm going to understand. I understand that rule. That's how the universe would look. That's how I have to be aware of the fact that what happens to me isn't what's happening to everything, okay, that I might be missing something. That the real universe might be doing a lot more stuff than I can appreciate because I'm only seeing what is interacting with me. And you just take that as like almost a Newtonian rule, then you wouldn't have gotten lost in all of this wooey bullshit in the first place. Because you wouldn't be able to go there. It wouldn't work if you understand that's the underlying truth. You don't see the photon that doesn't hit you. Okay, so anyway, till next time, and such, so forth and whatnot. Okay, yeah, the comments are useless, so sorry. I'll read them eventually, but they're just, you know, it just isn't anything to, nothing to feed on this medium.